Welcome to MathLink Academy, where we connect the dots. I am Mr. C, and in this particular unit, we're going to cover volume. We're going to talk about two shapes. We'll talk about a cone, and also we're going to talk about the pyramid. And so let's get started. So let's look at a few definitions here. A pyramid is a polyhedron whose base can be any polygon and whose other faces are triangles that meet at a common point called the vertex, the high peak. The triangular faces that meet at the vertex are called lateral faces. A lateral edge is a line segment where two lateral faces meet. And then the altitude, or we sometimes call it the height, of a pyramid is the perpendicular segment from the vertex, the tip, down to the plane of the base. Let's continue to look at some drawings and how those definitions come into play. Pyramids are named according to the shape of the base. So you need to know the base shape, and that gives you the name of the pyramid. So let's look at what we have here. So for the first one, we have a regular triangular pyramid because, and from left to right, this is a triangular. The blue color that you see is actually the base. That's the base of a triangle. Here's our vertex. Here's our altitude, the height. We have a lateral edge, which is right here. And then the lateral face would be this shape here as a triangle in this case. Another name of a pyramid could be called a regular quadrangular pyramid. And in that case, our base is a square, or as more as a, sometimes it could be a rectangular, but it's that square looking base, which is on the bottom, which is blue. And again, we have our height, a vertex, a lateral edge. In this case, we have a few lateral edges here, 1, 2, 3, 4. And then from those lateral edges, we have those lateral faces that are made from those lateral edges. Our next one we have here is a regular hexagonal pyramid because it has those 6 on the bottom on the base. We have that polygon that has 6 sides. And that's a hexagon. So we talk about hexagonal. And so again, all these comes from the base to give the name of a pyramid. Now, we're also going to look at cones, which I like. A circular cone is a solid form with a circular base and a surface that tapers from the base to a point called the vertex. So let's look at that. And as I'm talking about each of these words and definition, you can see this is our base. And this is called a right circular cone. Why it's called a circular cone? Because the base is circle, and then it gets narrow, narrow, narrow on the top, and it forms at the vertex, at the very tip, the vertex. The height, or the altitude, is perpendicular from the vertex, or line from the vertex to the base. We also have axis, and we have a lateral face. Our lateral face goes all the way around from the base all the way up to the vertex as it gets narrow now to the vertex. Now, here's our formula. And again, you can't see everything. I'm going to put that on our slide, what's missing. The volume of a regular pyramid or a right circular cone. So understand this formula stays the same for a pyramid, a regular pyramid, and also a right circular cone, okay? So the volume is equal to 1/3 of the area of the base, wherever that shape is, if it's a circle or rectangle, whatever the case may be, times the height. Now, why we use 1/3 is because we understand that we're losing some volume, and it's not just a right cylinder. If we had a right cylinder, we'll just say won't have the 1/3. But since we're looking at cones and pyramids, we're losing that. That's what I mean by that is we will not have a consistency going from bottom to top or top to bottom. We actually will have something that will have the circular, but then it comes to a vertex. And that's where that 1/3 comes in. So it's 1/3 times the area of the base times the height. And that's our formula for both of those shapes. So let's look at an example, see how we can do this. It says compute the volume of a pyramid that has a base of 24 square feet and a height of 6 feet. So let's do this one. So for this particular one, I don't necessarily have to draw the picture because it told me that the area of the base, they already figured that out, was 24 square feet. And the height is equal to 6 feet. So it's already given me those values. So since I know it's a pyramid and I want to find the volume, we know the volume formula is equal to V is equal to 1/3 area of the base times the height. Now let's go use a blue color so we can show you how the work is done. So this is 1/3 of 24 times 6. So let's make sure we do this correctly. When we multiply all three of those numbers, I believe this should be 48. Now you got to make sure what's the unit. So make sure you do it before me since we're talking about volume. Right, the units would be cubic feet. Cubic feet. So let's circle that. And that's what we have as an answer for this particular problem. So here's another example that we're going to look into. A disposable plastic drinking cup is designed to be in the shape of a right cylinder cone. The cup holds 1/3 pint, which gives us 9.63 cubic inches of liquid when full. The rim base diameter is 3.6 inches. Find the cup's depth or the height. So in this case, we're given a few things and we want to find the height. So we understand that the shape, and let me see if I can draw this shape for you, of the cup is going to look like this. And what we want to find is the height. This is what we want to find, the height. How high? Since that's the shape, our formula is V is equal to 1/3 the area of the base times the height. So what we know that 9.63 is, in our case, this answer would be the volume. So 9.63 is actually the volume, which is equal to 1/3 times the area, whatever that looks like, times the height. Now to find the area of the base, our base will be a circle. And we need to know how to find the area of a circle. The area of a circle is pi times r squared. So in this case, it'll be 3.14, that's our pi, times, in our case, they gave us the diameter. So we need to take half of 3.6 because it's the radius. But in that case, it's 1.8 squared. So let me actually clear this so you can see exactly what we have. So you can look at it right now. I'm going to clear this and rewrite it using what we have here so you won't be confused. So our volume again is 9.6 cubic inches. 6.3 is equal to 1/3 times the area of the base, which is 3.14, times 1.8, half of that number because we're using square, and then times h. H's are unknown. So in this case, and this is multiply, put that little dot there. Let's square 1.8. So square that, multiply by 3.14, and divide that by 3. So I believe we probably end up close to, let me see, 3.3912. I think that's what we have about. And then that'll be our answer with those numbers times h. So go ahead and try that on your calculator and see if you get that same number. Now, next thing we're going to do is get h by itself by dividing by 3.3912 on both sides. Now, when we do that, let's put this in green so you can see it. This will cancel, and we'll get h by itself. I'm going to put h over here. So it'll be approximately, if you see that in green, I'm going to say around 2.84. And since we got to have the units, and it's just the height, it'll be just inches. And that will be our answer, 2.84 inches for this particular problem. We're going to stop there for now. And if you have any questions, again, look at this video again, look at some of our supplementary material on our MathLink website, and make sure you understand how we got these particular answers and using the formula correctly to get the answers for these shapes that we talked about. Again, let MathLink bring it together, and thank you for watching this video.